Hello, good morning everyone. Today we are going to do second part of class 9 science chapter number 4 structure of the atom. We have learnt in Dalton's atomic theory in chapter number 3 where we were told that an atom is indivisible and indestructible. We have learned in chapter number 3 that an atom is indivisible. That means we cannot divide further. But when the discovery of this electron and proton was done, then it was made clear that no atom is divisible. That means atom can further be divided. The discovery of the two fundamental particles, the electron and proton, inside the atom made Dalton's concept, Dalton's atomic theory wrong. It was then considered necessary to know how electrons and protons are arranged. When our scientists came to know that atom is divisible and in that electrons and protons are there, then they became curious to know how these electrons and protons are arranged within an atom. Many scientists proposed various atomic models, but J.J. Thomson was the first one to propose a model for the structure of the atom. So we will study about Thomson's J.J. Thomson's model of an atom. Here it has been given to us about J.J. Thomson's model of an atom. J.J. Thomson proposed to us his model of atom in 1903. And that time only electrons and protons were known. As we have already seen earlier that the discovery of this proton and electron was done by that time. So when he proposed about the model of an atom, he considered that atom has got electron and proton. At that time neutron was not discovered. So he told that this atom is like Christmas pudding. He proposed that this atom is like a Christmas pudding, where the electrons in the sphere of a positive charge were like the dry fruits in a spherical Christmas pudding. You all must have seen Christmas pudding. As you can see the diagram on the screen, what happens? This Christmas pudding has got dry fruits in them. The dry fruits were considered to be the electrons, and the whole sphere remaining part were considered as the positive charge. He told that we can also think of this atom as a watermelon, where the positive charge in the atom is spread all over, and the red edible part of the watermelon, the positive charge is all over like the red edible part of the watermelon, as you can see in the diagram on the screen. And then the electrons were the seeds in the watermelon. The black color, that seeds that you are seeing, they were the electrons, and the red part was the positive part, the positive charged one. Thus, he told that in this way we can understand the model of an atom. J.J. Thomson proposed that an atom consists of positively charged sphere and the electrons are embedded in it. Embedded means gutha hua hai. The negative and the positive charges are equal in magnitude, so the atom as a whole is electrically neutral. What he told, that the positive and the negative charges, that means as many negative charges are there, same are the positive charges, and for they are equal in number and hence equal in magnitude, and so the atom as a whole is electrically neutral. J.J. Thomson told that the atom is electrically neutral, but when other scientists they performed experiments, the results of the experiment carried out by other scientists could not be explained by this model. That means there must be something missing, that we came to know later on that there was neutron also, and that led to the discovery of neutron. Now we will see the next part, Rutherford's model of an atom. Before studying Rutherford's model of an atom, we need to know few terms. For example, alpha particle. What is an alpha particle? So an alpha particle is a positively charged particle having 2 units of positive charge and 4 units of mass. In reality, it is a helium ion, He2 plus. He2 plus. These alpha particles are He2 plus. Alpha particles are given out by radioactive elements like radium and polonium. And it is considered that if alpha particles are moving very fast, then they have a considerable amount of energy in them. They have so much energy in them that they can penetrate through matter to some extent. Next term we need to know here is a gold foil. What is a gold foil? A gold foil is a very thin sheet of gold. And alpha particles are much smaller than the gold atoms present in the gold foil. Now we will see Rutherford's model of an atom. This Ernest Rutherford, he was very interested in knowing how the electrons are arranged within an atom. So he himself designed an experiment for this. And in this experiment, he made use of fast moving alpha particles. And therefore, this experiment is also known as Rutherford's alpha particle scattering experiment. This experiment is known as Rutherford's experiment, or it is also known as Rutherford's alpha particle scattering experiment. So in this experiment, what it was done, or how was this experiment done? He selected a gold foil. And why he selected gold foil only? Because he wanted as thin a layer as possible. And the gold foil was about 1000 atoms thick. So when fast moving alpha particles were allowed to strike a very thin gold foil in vacuum, it was found that most of the alpha particles pass straight through the gold foil without any deflection. It was also found it was also found that a few alpha particles as you can see in the diagram, a few alpha particles were deflected by the foil by small angles. Third thing it was found was that 1 out of every 12,000 particles appeared to rebound. See here the diagram nicely. What it was told that most of the alpha particles, it was observed that most of the alpha particles passed straight through the gold foil without any deflection from their original path. It was also observed that a few alpha particles bend to small angles, less angles, and a very few rebound on hitting, rebound, coming back in the same direction from which direction it was going. 1 out of every 12,000 particles appeared to be rebound. Let us think of an activity in an open field to understand the implications of this Rutherford's model, Rutherford's alpha particle scattering experiment. Let us think that a child is standing in front of a wall with his eyes closed. Let him throw a stone at the wall from a distance. What will happen? He will hear a sound. Each stone strikes the wall. Although his eyes are closed, but he is standing in front of a wall. So each time he will throw a stone towards the wall, the stone will strike the wall, and each time he will hear a sound. But if a blindfolded child were to throw a stone at a barbed wire fence, wire fence means it is not a wall, ऐसी दीवार जिसमें कि कांटेदार तार बांधा हुआ हो. That means most of the space will be empty. So when he is told to throw a stone towards that barbed wire fence, then what will happen? Most of the stones would not hit the fence and sound will not be heard by him. Only a few times he may hear, because there are lots of gaps in the fence and that gap allows the stone to pass through them. But in this alpha particle scattering experiment, most of the alpha particles passed straight. So we can say that most of the space inside the atom is empty. So here we have been given that these are the conclusions we can get from the alpha particle scattering experiment of Ernest Rutherford. Most of the space inside the atom is empty. Why? Because most of the alpha particles passed through the gold foil without getting deflected. Very few particles were deflected from their path indicating that the positive charge of the atom occupies very little space. Very little space. Very few particles were deflected from their path. See, alpha particles are also positively charged, and it is told, it was supposed, and still it is believed that the center is positively charged. So, if very few particles deflected from their path because like charges repel each other, that means the atom occupies very little space. Positive charge of the atom occupies very little space. A very few fraction of the particles were deflected by 180 degree. By 180 degree, indicating that all the positive charges in the mass of the gold atom were concentrated in a very small volume within the atom. This Rutherford also calculated the radius of the nucleus is about 10 to the power 5 times less than the radius of the atom. So after performing this experiment and many more experiments, Rutherford gave some conclusion. And the conclusions were that there is a positively charged center in an atom called the nucleus. Nearly all the mass of an atom resides in the nucleus. Second point, he told, the electrons revolve around the nucleus in circular paths. Third point, he told that the size of the nucleus is very, very small as compared to the size of the atom. But you all know that everything has got two sides. A coin has got two sides, head and tail. In the same way, if there are some advantages, if there were some good points about Rutherford's model of an atom, then there are some bad points, or we can say there are some defects, we can say some drawbacks in the Rutherford's model of an atom. So we will see about the drawbacks of Rutherford's model of an atom. So the major drawback was that Rutherford model of an atom did not explain the stability of the atom. The revolution of the electron in a circular orbit is not expected to be stable. Any particle in a circular orbit would undergo acceleration, and during acceleration, charged particles would radiate energy, and thus the revolving electron would lose energy and finally fall into the nucleus. If this were so, the atom should be highly unstable, and hence matter would not exist in the form that we know. We know that the atoms are quite stable. See, try to understand what it is being told in this paragraph, that if a particle is rotating, if any particle is moving in a circular orbit, then it undergoes accelerated. That means its motion is accelerated. Acceleration takes place. And when acceleration takes place, then what happens? The charged particles give out some energy. And when energy is giving out, then after revolving for some time, there will be loss of much energy. A time will also come when almost all the energy will be lost. And when all the energy will be lost, then what will happen? That rotating particle will have no energy and it should collapse into the center. But what we know about the atom? We know about the atom that it is stable. It does not collapse. Its electrons does not collapse. Then Rutherford was asked to explain this, that how it happens that the atom is stable. Rutherford was unable to give answer to this question. That means Rutherford's model could not explain why the atom is stable, why an atom is stable. So this is the major drawback of Rutherford's model of an atom. So what happened in 1913? See, this Rutherford, what he had done, he had given us this experiment. He had performed this alpha particle scattering experiment and could not give the explanation for the stability of an atom. Then in 1913, Niels Bohr, another scientist, came forward with some idea, and he told that I will give you the explanation why the atom is stable. So now we will study about the Bohr's model of an atom. So in Niels Bohr, see here about the Niels Bohr, it has been given to us that Niels Bohr, he gave us some idea, but he did not give us everything of his own. He gave to us some of the idea that was already told to us earlier by J.J. Thomson and by Rutherford. So what he told that an atom is made up of three particles: electron, proton and neutron. He told something more is there. Something more is there. So in order to overcome the objection raised against Rutherford model of an atom, Niels Bohr put forward the following postulates. He told only certain special orbits known as discrete orbits of electrons are allowed inside the atom. That means some particular orbits of electrons are allowed inside the atom. While revolving in discrete orbits, the electrons do not radiate energy. So how you will understand first point? What does this first point mean? This first point means that the electrons could revolve around the nucleus in only certain orbits or certain energy levels, and each orbit having different radius. The electrons in each orbit has got characteristic amount of energy. The electrons which are in orbit close to the nucleus has low energy, while those in orbits farther away from the nucleus, they have got higher energy. And what does the second point mean when he told that while revolving in discrete orbit, the electrons do not radiate energy? He meant to say that it was told that when an electron is revolving in a particular orbit or particular energy level around the nucleus, the electrons do not radiate energy, they do not lose energy, even though it has accelerated motion around the nucleus. And since the electrons do not lose energy while revolving in certain permitted orbit, they do not fall into the nucleus, and hence the atom remains stable. Hence the atom remains stable. And he told that these orbits or shells are called energy levels, and every level in an atom is shown here in this figure. The nucleus, the first one the K shell, next one the L cell, third one the M shell, fourth one N cell, and so on. He told these orbits or shells are represented by K, L, M, N or the numbers 1, 2, 3, 4, etc. Next, in detail about the Bohr's model of the atom and the remaining part of this chapter we will see in another video. Thank you.